welcome back for example 3. This will be our last example in 9.1. We've been talking about geometric sequences. In section 1, example 1, we learned how to recognize and extend a geometric sequence. And in example 2, I showed you a geometric sequence formula that could help you find any number in a sequence. And now example 3 is kind of pulling everything together, and we're going to apply it to a word problem, which is really good practice for the state test as well as your Terra Novas. So here's example 3. Well, I'll do the top and I'll leave the bottom one here for you, okay? So I'll just draw a line there, kind of break that up a little bit. All right, let me do example 3, the top for you. A bungee jumper jumps from a bridge. Each successive bounce forms a geometric sequence. On his first bounce, the bungee jumper's height was 200 feet. On his second bounce, his height was 80 feet. On his third bounce, his height was 32 feet. What's the bungee jumper's height at the top of the 5th bounce? So basically, let's say the bungee jumper's up here and takes a nosedive, woo, and then boing, boing, boing. That's what's going on. It's just getting lower and lower and incrementally lower each time. Okay? So what you see here, I hope what you see is a sequence. Now, they didn't write it out linearly for you. Here's the first bounce. Here's the second bounce. Here's the third bounce. And it continued until, the bungee jumper just stopped bouncing eventually. So they want to know, what's the bungee jumper's height at the top of the 5th bounce? Well, the question actually gave us one piece of information. We now know what n is equal to. So we know n is 5. We know that in the sequence, 200 is the first number in the sequence. So we'll put 200 as a sub 1. We need to calculate the common ratio. And so remember, take the second number, divide it by the first number. And it's okay if it's a decimal, not a big deal. So we'll do 80 divided by 200. And it is a decimal, so it's going to be exactly 0.4. Now, once you have those pieces of information, it's easy from here. You're just going to plug into the formula. So we're going to try and find the 5th term. And so we started at 200 feet, and we're progressively dropping 4/10, and we're raising that to the 5 minus 1 power. So if we clean it up and get a calculator ready, then this is really what we're looking for. 200 times 0.4 raised to the 4. So key that in, practice with me. You guys know we like to practice. I like it when you practice. And you'll see that the height of that 5th bounce is just a smidge over 5 feet. And that's it, okay? So there's that 5th bounce. That person ended up, just bouncing merely 5 feet. Compared to 200, that's not that much, is it? So that's it. That's just an application. It's more of what we did in the last example. It's just applied to a situation. So now I'm going to have you do the bottom for your extra credit, okay? And I'll go ahead and give 1 point for that. And your situation is this. You're tracking a car's value for 3 years. So year 1, the car was $10,000. By year 2, it had dropped in value to $8,000. Year 3, it dropped in value to $6,400. So what they want you to do is they want you to find out, well, how much will the car be worth in 10 years? And on that 10th year, how much is the car going to cost, or how much is it worth? Because we know they devalue year after year after year. So find your n, find your first term in your sequence, calculate your r, plug it into the formula, and tell me that car's value in the 10th year. Okay? Good luck with that. Thanks for listening.